Good morning, guys. So we'll start with the next portion of the chapter AC, which is AC in LR circuit. AC in LR circuit. Now, you will not see this portion in that is AC in LR circuit in your NCERT textbook, but this is important in the case of if you are preparing for NEET, IIT, JEE preparation. Okay, so AC in LR as well as the next topic will be AC in RC circuit. We'll finish these two topics in this video itself. Okay, so as you understand from the name itself, LR circuit means it has an inductor and a resistor. So when you draw the circuit, it will be resistor and an inductor, right? And it is connected to an AC supply, right? Let's say the resistance is R ohm and this is an inductor. Let's say XL is a reactance of this inductor. So this is having XL ohm and R ohm is a resistance. Right, let's say I of t is the current which is flowing through this circuit. Right, so this becomes plus minus plus minus. Right, the voltage across the resistance, let's name it as VR, and the voltage or potential difference across the inductor, let's name it as VL. Okay, now since I just told you I of t is the current which is flowing through the circuit, let's say that I of t, right, I'm going to write it as I naught sin omega t. Let's say, right, it's a sinusoidal waveform, hence I am writing it in this form. Right, now when the current is flowing through this, right, so there will be potential drop VR and VL, right? So I can write VR of t, that is across the resistance, I can write as what? Current into, right, I have to supposed to write it as IR sin omega t. Right, why? If I is I naught sin omega t, then the voltage will also be, actually it is actually what? V naught sin omega t, right? In place of V naught I wrote it as I naught R, right? Now why did I write it as sin omega t? In the case of resistance, voltage and current are of the same phase, right? So then VL of t, that is a voltage or the potential difference across the inductor, which we have taught, or which I have taught you earlier. In the case of inductor, the current lags behind EMF by a degree of pi by 2, right? 90-degree lagging is there in the case of current, or I can say the voltage, right? That is V naught, right? I would have written it as epsilon and epsilon naught. It's okay. I just told you before also I can write it as V also, right? It is V naught, right, sine omega t. That current is lagging means voltage is leading, right? So I can write it as pi plus pi by 2. If current is sine omega t, then the voltage will be omega t plus pi by 2, right? This much is clear. So this V naught I can write it as I naught into the resistance or the reactance of the inductor, right? Sine omega t plus pi by 2. Right, you got two equations for VR and VL, clear? Now suppose I want to find the net voltage through both the resistance and inductor, then the net voltage will be what? Resistance voltage plus voltage across the inductor. So I just have to add these two guys, that is I naught, right, R sin omega t plus I naught XL sin omega t plus pi by 2. Right, now you can see both this waveform are in simple harmonic motion. Right, you have learned about simple harmonic motion in your 11th class. Right, the net EMF also will be simple harmonic motion. Right, when two simple harmonic motions are added, then the result is also a simple harmonic motion. And what is the amplitude of these two simple harmonic motion? This is I naught R, this amplitude. I naught XL is the amplitude of the second simple harmonic motion. Right, so that means the net, right, the net impedance or net voltage, if I want to find the net voltage amplitude, right, how would I find it? How can I find that one? let's say I'm drawing a black, oh no, graphical representation for it, right? I naught R, right? See, I naught R is a representation for voltage actually. This is I into R. So that is actually voltage. Now I told you before, in the case of resistance and or in the case of resistance, current as well as voltage is in the same direction, right? So I can assume this is the direction of voltage as well as current. Right, so the current direction I naught is in this direction, or in the case I can just say I naught R is in this direction. Then since inductor's voltage, right, inductor's voltage will be leading, right, voltage is leading by 90 degree, means this will be 90 degree. So this will be the voltage VL, or the amplitude only if I am writing it becomes I naught XL. Right, so this is the indication of amplitudes of the simple harmonic motions of both of them, right? This is I naught R, this section, and this is I naught XL, that is this section, right? And net will be in this direction, right? It's just like vectorial addition, guys, right? The net vector or net voltage is in this direction. Let's say it is making alpha from this now with I naught R. So can't I write V net is equal to root of I naught R whole square plus I naught XL whole square, right? Simple. Keep that as mine, or I am going to write it again in the below portion. Let's change the color, right? It is V net is equal to root of I naught, just like vector addition, R squared plus I naught XL whole square, or I can bring I naught outside, so I naught root of R squared plus XL whole square, that is V net, right? That means we know voltage is current into resistance, so this much factor is acting as a resistance, as this is known as a reactance of an LR circuit. Which part? This one, right? And it is indicated by Z. So Z is equal to root of R squared plus L squared. You can write it in separate also. That is Z is equal to root of R squared plus XL squared. Keep that in mind. This is the impedance or the reactance of LR circuit. You can also call it reactance, or usually it is called impedance. Clear? Keep that in mind. So this XL also I can write from the previous class. I have told you XL is equal to L omega, so I can even write it as this form. Z is equal to root of R square plus L omega square, right? Clear? So we had a figure, remember, like this. This was V net, and this was the direction of I naught R, and this was the direction of I naught XL, right? So this angle was alpha, right? So from here I can change little bit thing. What is tan alpha? If I draw this section, if I draw a triangle like this, what is tan alpha? You can easily find tan alpha, right? Tan alpha is equal to I naught XL divided by I naught R, or XL by R, right? Or I can say alpha is equal to tan inverse XL by R. Keep that in mind. These are all parameters we require while solving problems, right? So this can be also made into a, remember this equation I can even draw as a triangle like this. This is alpha, this is XL, right? Opposite side by base, right? So this is root of XL square plus R squared, right? Or I can write it as just Z, right? Or this triangle which I just drawn is known as impedance triangle. This triangle is called impedance triangle. Clear? Right? Right, we have just brushed a lot of topics because this topic is not required in the case of your single figure. That's why I'm running. Okay. So net voltage, see how can I write the net voltage now? If this is, let's draw the diagram again, the graphical representation. It was like this, right? This was the net voltage, right? And this was the direction of I naught R, right? Or I can say, since I naught and voltage is of the same direction, I can even remove this R, right? I can say the current direction is in this direction, right? And this is alpha, right? Something which you have learned again and again, right? Now what is V net? We just talked earlier. V net or V of t, as per the earlier section, right? It was what? I naught, right? As per the diagram, I can say I naught into, that is the current into the impedance of the circuit or the resistance of the circuit was what? R squared plus XL squared sine omega t. See, current direction is this one, whereas the net voltage of this entire circuit is at a alpha phase difference with respect to current. We wrote earlier current is I naught sine omega t, right? So, voltage or the potential shiftness should be plus alpha compared to the phase of the current. So, this equation has to be made into this form. That is V net is equal to, I'm going to write it again guys, V net, net voltage is equal to V0, if you want to, you can like that, write like this, sine omega t plus alpha, and this V naught is I naught into root of R square plus XL square sine omega t plus alpha. This is the voltage of an what? LR circuit. What was current? I is equal to I naught sine omega t. So I can easily say that the voltage of an LR circuit is leading the current by an angle alpha. And that alpha is tan inverse of XL by R. Clear? Right? Simple. Now, this impedance triangle, remember we had impedance triangle, sometimes that is, this was I naught R, right? This was I naught XL, and this was V net, or I can write it as I naught root of XL square, sorry, plus R squared, but this and all term are having common I naught, right? So I can even draw a graph like this also. This is R, this is XL, and this is root of, or I can say this is a root of XL square plus R square, or I can write it as just Z, right? There's another form also. This is alpha, right? It's not something which you can generate by yourself. Clear? Right. After this portion, we'll go for the next segment, which is CR or RC circuit. That is, you are having a resistor and a capacitor. Right, it's much more easier when you understood the previous section. This is much more easy, right? So in the RC circuit, what and all is present? There is a resistance, there is a capacitor, right? And there is an AC supply. Let's say this is R, this is C, right? And X is the reactance offered by this capacitor, R is the resistance offered by the resistor. Let's say I of t is the current which is flowing through here, right? Clear? This is plus minus, right? Now what is the current? Let's say assume this current is a sinusoidal form. It is I naught sine omega t, right? So what will the resistance voltage? Just like the previous case, it will be V naught sine omega t. In place of E naught, I will write it as I naught R sine omega t. That is the case of VR of t, voltage across the resistance. Now, what will be the voltage across the capacitor, which we have learned earlier? In capacitor, the current leads the voltage by the angle pi by 2 or 90 degree, or I can say voltage lags, right? So across that I will write, V naught sine omega t minus pi by 2, right? Current is leading voltage, so that means voltage will be lagging current, lagging behind current, right? That is the meaning. Both of them are having the same meaning. So I can write it as V naught, In place of V naught, I will write I naught XC sine omega t minus pi by 2. That is our VC of t. Right, so you have an equation for resistance voltage and voltage across the capacitor. Just like the previous case, what will be the net voltage? Net voltage will be the sum of VR of t plus VC of t across each one. Right. What is the resistance voltage? We wrote it as I naught R sine omega t. And what is voltage across capacitor? I naught XC sine omega t minus pi by 2. Clear? So this is something which you have learned just like the previous cases. So these two are again sinusoidal waveform, or I can say simple harmonic motion, and these are the respective amplitudes. So just like the previous case, I can draw the diagram, right? If this is I naught R, right, capacitor's voltage lags behind the current by 90 degree, means this will be I naught XC, and this will be the net voltage direction, and this will be alpha. Let's say, so what is V net? V net, just like the vectorial addition, it is I naught R whole square plus XC I naught whole square, right? That can bring I naught outside, will be R square plus XC square, right? This is our net voltage amplitude. Phase has not been written till now, right? Clear? So this section, right, voltage will be current into resistance. So this section is called impedance of an RC circuit. So it is also indicated by Z. So Z of an RC circuit is root of R square plus XC square. Right. So this can be also represented by a impedance triangle. Right. So like this. So draw like this Z, right? This becomes R and this is XC. This is Z is equal to root of R square plus XC square, right? This is alpha then. Then tan alpha, or alpha is equal to tan inverse XC by R, just like the previous cases. Simple, right? So now I am going to write the entire voltage with the phase section. So I can see from the diagram itself what is happening. The net voltage, right? Net voltage. Okay, and let's see with the figure. Right, this is the net voltage direction and the current is like this. So net voltage is lagging, right? Remember, this was the direction of current. This is the direction of V net and this is alpha. So net voltage, when I write, it will be V naught sine omega t minus alpha, right? In place of V naught, now I will write it as V net as equal to I naught Z sine omega t minus alpha, or I can write it as V net as I net root of R squared plus XC squared sine omega t minus alpha, that is V net. What was current? Current was I naught sine omega t. Right, so I can say in the case of an RC circuit, voltage lags behind current by an angle alpha, and alpha is equal to tan inverse XC by R. Simple? Clear? Now let's do a simple problem, guys. Suppose this is a circuit which is given. This is a numerical problem we are going to do, and this is an inductor, say, right? This is XL, let's say it is 3 ohm, and the resistance is of 4 ohm, right? And you are having a supply AC which is of EMF E is equal to 20 sine omega t plus 60 degree, right? You are asked the following questions. What is the value of Z, alpha, I naught, IRMS and I of t? These are the following things we are supposed to find. So let's move on with the first section. What is impedance? Z we have found the equation, remember it is r squared plus x squared's root. It is root of what is r squared is 4 squared. What is x squared? 3 squared, right? So it is 3 squared, that is equal to root of 16 plus 9. It is root 25. You will get the answer as 5 ohm. That is our Z. Easy. Right. Now similarly, let's move on with the second section. You are asked what is alpha. It is tan inverse what? XL by R. Now how can I find XL? XL you are given the value as 3 and R is 4. So tan inverse 3 by 4. No, that is angle is 37 degree. I have taught it. If you are having a triangle like this is 3, this is 4, this is 5, then this angle is 37 degree. If this becomes 4, this becomes 3, then the angle is what? 53 degree. That also I have taught. Anyways, the next third one was what? You were asked what is V naught. V naught is equal to I naught into Z, right? Or I can write I naught is equal to V naught by Z, right? So V naught you are given from the equation, guys. See, the is given as V naught, or it is epsilon naught, right? So epsilon naught or V naught same. So it is 20 given. So I will write this as 20 divided by what is Z value? You just found it as 5. So you will get 4 ampere as your peak current, right? Then the next question which is asked is what? You are asked the fourth option. You are asked as what is IRMS? RMS current. RMS is 1 by root 2 times peak current. What is peak current? 4 divided by root 2. You can write it as 4 root 2 by 2, or it is 2 root 2 ampere, right? Simple. Now similarly, what is the fifth question which is asked? You are asked what is the equation, that is right current form. Current form is I naught sine omega t. If EMF or V is V naught sine omega t plus alpha, right? If this is the equation form, then this is the current form. That is the meaning, right? Or I can say in the case of capacitance, or sorry, in the case of LR circuit, we learned that there is a phase difference of how much alpha between current and voltage, right? Or I can say the voltage is leading, right? So we are just given what is the actual voltage equation given here. V is equal to 20 sine omega t plus 60. So it doesn't mean this alpha is 60, okay? Or you can take it, okay. So you mean that this alpha must be removed from here, right? This equation doesn't have any alpha. So your actual equation should be 60 degree minus of this value, right? See, omega t actual equation is this one. So you given alpha here. So this alpha is not there in our current, right? So what will be the current equation? I of t will be I naught. I can write it as 4, which was found by earlier, sine omega t plus 60. That is our what? Value which is given in what? EMF, right? From there I have to remove alpha, right? So from this equation, if I remove alpha, then only I get this section. So similarly, in our question, we are given this as this much is the value of what? Voltage. From there I have to remove alpha, right? So I'll write 4 sine omega t plus 60 minus 37, right? So you'll get the answer as 4 sine omega t plus 23 degree. That is your current equation. Easy, right? Okay, we are going for the next question, guys. You are seeing a question, right? When a DC supply of 20 volt is applied to an LR circuit, there is a circuit which is having an inductor and resistance. Then, after a long time, a current of 5 ampere flows through it, right? If same circuit is connected to an AC supply, then another current of 4 ampere flows through it, right? Either in first section you were connecting to DC, right? So after a long time only 5 ampere current flows, right? So we'll go for that scenario first, right? So you're having a supply of a DC and it is connected to a resistance R, right? And you are having, after a long time only the current flows, right? And the DC case, at that time the inductor will act as a short circuit, right? So this is our inductor now, right? At that time a current I only flows and that current is 5 ampere, right? And the voltage is 20 volt, right? I didn't tell you what to find, right? You're supposed to find what is the value of L and you are supposed to find the value of R. What would be the resistance value and what would be the inductor's value, right? Now this is the first scenario. This much is given, right? Can't I find the value of resistance from here itself? R will be equal to what? Voltage by current, right? So what is the voltage? It is 20, and what is the current flowing? That will be 5, so that will be 4 ohm, right? So this resistance is of 4 ohm. Simple, right? Just like the previous, right? Why I just told you, right? After infinite time, when it is connected to a supply of DC, the inductor acts as a short circuit, right? Now after this, now this entire scenario is connected to what? With an AC supply, right? And this AC supply is having some specification. What is the current which is flowing out, right? Which is given as how much? 4 ampere. That current is RMS current, right? That is not a peak current, it is RMS current which is given as 4 ampere, right? Now anything else given? You are given 20 volt and 50 hertz supply, right? So 20 volt is its VRMS or ERMS, which is 20 volt, right? So can't I find Z from it? How? We know that V0 is equal to I0 into Z. The previous cases I have told you, Z is the impedance of the circuit, right? So this, if I divide with root 2 and this is also divided by root 2, this is becoming VRMS and this is our IRMS and this is Z, right? So you are given VRMS, you are having IRMS, you can find the value of Z. So you, after calculation, you will find Z's value as 5 ohm. Calculate by yourself, okay? You'll get it as 5 ohm. Take your time. I hope you understood what we did, right? You have the equation, right? That is V0 is equal to I0 into Z, right? In place of V0 I wrote by divided by root 2. Then if I am dividing this as by root 2, then this has to be divided by root 2. So peak voltage by root 2 is RMS voltage, peak current by root 2 is RMS current. So you will get VRMS is equal to IRMS into Z. So you know VRMS is the IRMS, you can find the impedance value which is 5 ohm. Simple, right? Now moving on, if I know Z, right? So Z I know in the case of an LR circuit is equal to root of R square plus XL square, right? That is equal to root of R square plus L omega whole square. That is also taught to you guys, right? Now what is omega? It is 2 pi by T or it is 2 pi F, right? You are given in the question itself the frequency is how many hertz? 50 hertz, right? So it will be 100 pi, right? So that will be the value of what? Omega. So you got the value of omega, right? Now moving on, you found the value of Z in the previous section itself. It is 5 ohm. Root of what is R's value? You found it as 4, right? So it is 4 squared plus L, I don't know, so L squared, omega squared, that is 100 pi whole square. So then you have to do the calculation, right? Later on after calculation you will find the value of L as how much? 3 divided by 100 pi. Clear? Calculation, please do it by yourself, guys, right? This is a problem which you are asked to do and we did 2 problems, right? So this is something which is asked in the NEET section, okay?